Welcome to this quick demonstration of regression to the mean. Regression to the mean doesn't mean that we get more careful with our money as we get older. It simply means that usually if you have a group of people competing together and the results are variable for various reasons, people who do badly in one round tend to do better in the next, and people who do better tend to do worse. So to demonstrate this, we're going to look at 4 people playing a game of dice. The way it's going to work is they're going to throw 5 dice 10 times. So they each have a fairly good crack at the whip, and they've all got their own belief. One player believes that blowing on the dice gives them more luck. Another person believes that shaking them very vigorously gives them more luck. Another believes that having a special magic coin gives more luck, and so forth. So they've all got reasons to think that they are doing well, but we're going to simulate it using a random number generator. Well, not really random, but good enough for this, called Jot. So Jot gives us some random numbers. Mine is half a random. Let's get 5 of them between 1 and 6. There we are, 3, 2, 1, 3, 6. They look pretty random, good enough anyway. And that's how we're going to get the score for each person. We want to add up the score. We don't want to do it ourselves manually, so let's replace those new lines with, so new line is called \n, new lines with a plus. We can add them up. And there we are, pluses. We don't want the first one to be a plus, so let's change that first plus to a space. And to get our desktop calculator to calculate these, you need a p. Let's show an example. Echo, so 2 plus p, and we give that to DC, which stands for desktop calculator. It gives us 4, so we need the same thing for our sum up there. So we can do that by echoing the whole thing. And we run Jot. And when Jot gives its results, we need to have a P after it. See if that does the right thing. Yes, those are the numbers. You notice each time they're different numbers because it's a random calculation with a P, and we can just give that to DC for desktop calculator again, and in that case it gives us 20. Of course, that's only for 5. In our game we're going to have 10 throws of 5 for each player, which is 50, so let's make that 50, and that's the sort of score we're going to get, something like 170. We're going to do this for our 4 players. In Jack and Jill. So those are our 4 players. And for each player we're going to work out the score. It's just going to be that sum that we've got here. So that gives us a score of that particular player. We're then going to work out the total, so we can work out the average later to see what the mean was. Plus the score. And we need to do a let for 4. That'll work it out. So it's going to take the total and the score to it. And we're then going to echo this into a little file so we can look at them sorted. So the score, the player, space, and then the player's name. And we'll put it into something called results. So now it will run. Let's have a look at the results. But we'll sort them. Right, so we've run this thing once, and we end up with Jill doing worst with 161, and Jim doing best with 195. If regression to the mean is correct, and they run another round, what we'd expect is that Jill will do better. And we'd expect that Jim will do less well. So let's do that. Now we've been using total to add up the totals. Let's just see what the total is. So the total is 692, which tells us that the average is 173. So Jack actually got the average score. Jim did better than average, and Jill and Joyce did less well than average. Regression to the mean just means that people at the outliers, at the edges, tend to move back towards the middle, back towards the mean. So let's see if that's true. I'll put our total back to naught. Don't use anything else. Let's remove results. And we'll run it again. Exactly the same thing as we did before. But remember, new rounded numbers each time. Let's now look at the results sorted and see what we get. And what does it look like? We expected Jill to do better because Jill did least well. Jill got 161 last time, and now we see Jill gets 193. Exactly what we'd expect. Jim, on the other hand, we expect to do less well. Jim got 195 and has now dropped down to 165. Our total is 715. $178. So very much it's 173, 178 this time. Actually, the mean doesn't matter too much. You can see what's happening. What happens at each time, the people at the far extremes are in an unusual position. It's unusual to be at an extreme, so it's more likely that they'll be closer to the center. Now, further away from the extreme, rather, one could say. So Jill was at an extreme of 161 and came out the next round at 193. Definitely moving away from being at the one extreme, in fact going to the other extreme. In this case, Jim, in fact, also went from one extreme to the other. Just for fun, let's run it again and see how they do this time. This time, it all relies on, well, this time we'd expect the opposite. Jim did least well and Jill did best. So if we run it again, sorry, let's just remove the results again so it doesn't have the old ones in there. We won't bother with the total this time. Let's just add them all, run them again. Cat results. And what do we get? Well, we expected Jim to do better than last time. And Jim got 165. Now Jim's got 177, which is what you'd expect. And we expected Jill to do less well. Jill got 193, and now Jill is down to 174. So that is, very simply, what regression to the mean means. If there's a variable result, it's nothing to do necessarily with the skill of the players, but simply that the extremes tend back towards the middle, to the mean.